Well, I definitely expected to be back in the classroom yesterday, and obviously I wasn't. So I'm narrating one because I figured that you probably will learn a little bit more fully if you can actually hear my explanation of what's going on with these. So, of course, this is our do now, and hopefully this is becoming old hat by this point that you're getting really good with the order of operations. But if you have not finished the do now, you should probably stop this playback and then resume when it's time to check some answers. Okay, assuming that it's time to check some answers, let's look at number one. Now remember, the numerator and the denominator have to be done separately as if they're inside parentheses. So in the numerator, I got exponent or subtract. Well, exponent would happen first. So 7 times 7 makes 49. And of course, 49 take away 1 would leave me with a 48. So there's my numerator. In the denominator, well, inside the parentheses, we take priority. 7 subtract 5 is 2. And then 3 times 2 makes 6. Finally, 48 divided by 6. Right? If you're a little kid, you see a fraction. If you're a big kid, you say, oh no, that's division. That's 48 divided by 6. So the answer is 8. Number two, I don't see parentheses. I don't see exponents. Oh, is there multiplying or dividing? Yes, there is dividing. Notice the 24 just sat there. The subtraction symbol sat there. The plus sign just sat there, and the 2 at the end sat there. All I did was add 8 divided by 2 to make a 4. Now, remember, it's add or subtract from left to right. Right? Subtraction and addition are the same in a hierarchy. So 24 subtract 4 is 20. Then we can add 2 and we get 22. Number three, top priority inside parentheses. I see addition, I see an exponent. Well, exponents happen before addition. So 2 squared, 2 times 2 makes 4. Still inside the parentheses, the only thing left is addition, so 1 plus 4 is 5. There's nothing else inside the parentheses I can do. I don't see any exponents. Is there any multiplying or dividing? Oh, yes, there is. That is 3 times 5. Right? That's what we call implied multiplication. If we don't see a symbol between the 3 and the 5, we know it's multiplication. Finally, 1 plus 15 is 16. Number 4, inside the parentheses. Well, if I see more than one set of parentheses, let's go left to right. Inside that first set, I'll do the exponent before I do subtraction. So 3 squared is 3 times 3, that's 9. Now I can do 9 subtract 7, I just come up with 2. In the other set of parentheses, I don't see any exponents. I don't see any multiplying or dividing. So I can do any adding or subtracting from left to right. So 10 subtract 7 is 3. I can add 2 to get 5. There is nothing left inside either set of parentheses. There are no exponents anywhere. Is there multiplying or dividing? Oh yeah, we got 2 times 5. 2 times 5 is 10. In the numerator, exponent or subtraction, well, exponent comes first, so 5 times 5 is 25. 25 take away 1 is 24. In the denominator, I got to do inside the parentheses first. 5 take away 1 is 4. Of course, 3 times 4 will get us a 12. 24 divided by 12 is 2. Right? Or you could view that as a fraction and reduce it to 2 over 1, which would be the same thing as 2. Right? Little kids see that as a fraction. Big kids see that as division. Number 6, inside the parentheses, I see exponents and subtraction. Got to do the exponents before subtraction. 4 times 4 is 16. 3 times 3 is 9. Still inside the parentheses, 16 subtract 9 will be 7. There's nothing else inside the parentheses to do. Look outside the parentheses. Aha, an exponent. 7 times 7 is 49. Okay, so our learning target today, super duper exciting, integer exponents, and I really regret not being in the classroom for this. This is actually one of my favorite things to do, one of my favorite things to teach. And so everyone is going to need to, hopefully this is on the back side of your do now, right? If it's not on the back side of your do now, we've got to pass some papers out real quick, but I think this is the back side of your do now. But if need be, pause the video until everybody has this paper in front of them. Okay, assuming that everyone's got a paper in front of them, I'm going to put 1/8 as the very first term, okay? Now, the directions say multiply by 2 to create the next term in the sequence. So 1/8 times 2. What is 1/8 times 2? Well, that would become 2/8, which reduces to be 1/4. Okay, now we got to do 1/4 times 2. What is 1/4 times 2? Well, it would be 2/4, which reduces to 1/2. 1/2 times 2, that'd be 2/2, which is 1. Ooh, now we're on easy street. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. Now, if you remember with our previous work with in-out tables and function rules, you'll remember that we should be able to see a pattern develop, right? If there's a consistent rule and we just consistently go to the next term, right, not jump around, we should see a pattern develop, right? And here, of course, it's like, hey, it just kept doubling, kept doubling, kept doubling. You also might notice that, where is my pointer? See this, the 2, the 4, and the 8? Notice there's a 2, 4, and 8 on the bottom of these fractions. You're like, hey, that 2 and that 4 and that 8, not only do they appear as 2, 4, and 8, they also appear as denominators on fractions. Interesting. And now here's a table that we're going to complete. I'm going to start giving you some bases and exponents. And we just want to evaluate the expression I give you. All right, so the first one we got copied down is 2 to the 5th power. What is 2 to the 5th power? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. All right, so 2 to the 5th power is 32. All right, we've done a lot of work where the exponent is a 2, but here, whoa, my goodness, exponent is 5. That's kind of big. Next one I'd like to have you figure out, 2 to the 4th power. If we evaluate this, I got to do 2 times 2 times 2 times 2. All right, I have to multiply 4 2's together. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. Now, again, with an in-out table or a function rule, if I see a definite pattern on the input, I should see a definite pattern on the output. Right? So I'm seeing a pattern with the input, right? I have 2 to the 5th, and then 2 to the 4th, and then 2 to the 3rd, right? The exponent's always going down by 1. So there's a definite pattern. I should see a definite pattern when I evaluate. So 2 to the 3rd power, 2 times 2 is 4, times 2 is 8. And hey, yeah, there's a pattern showing up. Right? 32, 16, 8. If I look up here, hey, yeah, that's that pattern that was doubling. But instead of doubling, it looks like I'm dividing by 2, right? 32 divided by 2 is 16. 16 divided by 2 is 8. But it looks like it's that same list of numbers that we got by doubling. Interesting. Okay, our next input following the pattern will be 2 to the second power. Right? I keep reducing the exponent by 1. And of course, 2 times 2 is 4. Okay, let's reduce the exponent by 1. 2 to the first power. Well, we've already talked about this. If the exponent is 1, we're just looking at the number, right? 2 to the first power is 2. And again, if I'm taking a look at this pattern, 32, 16, 8, 4, 2, right? That's what we had up here. There's that 32, there's that 16, there's that 8, there's that 4, there's that 2. Of course, in the pattern up here, I kept multiplying by 2. Pattern here, it looks like we're dividing by 2, right? 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. Okay, now I keep taking 1 off the exponent, so the next one has to be 2 to the 0 power, right? 1 take away 1 is 0, so I'm looking at 2 to the 0 power. What is the answer to 2 to the 0 power? Well, it's got to follow the pattern. If 8 divided by 2 is 4, and 4 divided by 2 is 2, 2 divided by 2 has to be 1. If the exponent is 0, the value of the expression is 1. Right? And again, take a look at this pattern we had up here. You said, yeah, I got a 1, a 2, and a 4. So I better see that same pattern here, right? I better see that 1, 2, and 4. So if the exponent is 0, the value is 1. Let's take another one off the exponent. 0, take away 1 is negative 1. We've got 2 to the negative 1 power. What is the value? Well, we've got that list up above. We kind of know what's going to happen. It looks like it's got to be 1/2. When the exponent is positive, it's telling me how many times I'm going to multiply by 2. If the exponent is negative, it tells me how many times I'm going to divide by 2. Notice when the exponent is negative, we don't have a negative number. Instead, we have a reciprocal. Take away 1 from the exponent, so now we're at 2 to the negative 2. Well, what number has to be next in the pattern? All right, half of 4 was 2. Half of 2 is 1. Half of 1 is a half. What's half of a half? A fourth. Right? If I cut a pizza in half, and then I cut my half into half, I've got a fourth of a pizza in front of me. Again, take away 1 from the exponent. I know I'm looking at 2 to the negative 3 power. Well, I know 2 to the third would be 8. Right? 2 times 2 times 2 makes 8. But there's a negative on the exponent, so I don't want to multiply. I want to divide. And instead of doing 2 times 2 times 2, I'll divide by 2, divide by 2, divide by 2. I get 1 over 8. Again, the key things here. If the exponent, come on, right? If the exponent is 1, we're just looking at the number, right? So 2 to the first power is just 2. If the exponent is 0, the value is 1. Right? 2 to the 0 power is 1. If the exponent is negative, we're looking at a reciprocal. Right? 2 2 to the negative 1 is 1/2. 2 to the negative 2. Well, 2 squared would have been 4, but there's a negative. Put the 4 on the bottom of the fraction. 2 to the negative 3. Well, 2 to the third would have been 8, but it's a negative exponent. Put the 8 on the bottom. Okay, now just pay attention here, right? You're not going to find this on a paper or anyplace, so just watch the screen. Okay, watch the screen here. Make sure your focus is up on the screen and you're looking at the screen, listening to my voice. X to the third power means X times X times X. So let's do an example with plain old numbers. All right, if I had 4 to the third power, it'd be 4 times 4 times 4. Right? The base is 4. I got to use 4. Exponent is 3. It says, hey, you better use 3 of them. Thank goodness we got calculators because these get big in a hurry. 4 times 4 times 4 comes out as 64. Second power, we've been doing a lot of these. All right? Let's look at an example with plain old numbers. 7 to the second power. I've got to do 7 times 7. All right? The base was 7. Exponent says, hey, use 2 of them. 7 times 7 is 49. And you should be pretty comfortable with exponents of 2 or 3. Here come the unusual ones. If the exponent is 1, you're just looking at the number. Let's do a flood of examples here. 8 to the first power, that's just going to be 8. 3 to the first power, 3. 5 to the first power, 5. Right? If the exponent is 1, you're just looking at the number. Next sneaky one. If the exponent is 0, the value is 1. Again, here comes a flood of examples here. 8 to the 0 power, 1. 3 to the 0 power, 1. 5 to the 0 power, 1. Right? Doesn't matter what the base is. If the exponent is 0, that tells me I'm not multiplying by the base. Right? So I'm just going to have 1. If the exponent is negative 1, we are dividing instead of multiplying. So once again, I'm using 8 as an example. Right? 8 to the first was 8. So 8 to the negative 1 is 1 over 8. Right? If 8 to the first is 8, if I have a negative 1 instead of a positive 1 in the exponent, I need 1 over 8. 3 to the negative 1. Well, I know 3 to the first power would have been 3, but there's a negative on the exponent, so it's 1 over 3. Again, notice a negative exponent does not make the answer a negative number. 5 to the negative first power. Well, that's just 1 over 5. Right? The negative on the exponent tells us that we're dividing by the base instead of multiplying. So if I see x to the negative 2, I rewrite that as 1 over x squared. Let's look at an example of plain old numbers. 6 raised to the negative 2 power. That really means 1 over 6 squared. Notice the negative is removed from the exponent because I put 6 squared on the bottom. Oh, great, Triton's barking to go out. And of course, 6 times 6 is 36. So the answer is actually 1 over 36. Right? It's like I took the number 1 and I divided by 6 twice. 1 divided by 6 is a 6. 1 6 divided by 6 is 1 over 36. Time for some independent practice. So it's probably time to pass out the next worksheet. And while you're working, you might find it useful if you rewind the video so those examples are up on the screen, right? So you can be reminded what happens if the exponent is 1, reminded what you do if the exponent is 0, and be reminded what to do if the exponent is negative 1. All right, so hopefully this helped you understand it. And I definitely super duper hope to be back on Monday after Thanksgiving break. Hopefully my health will be back to normal, and I'll be able to be in person, because I'm certainly really getting tired of staring at the walls at home. So hope to see you Monday. Good luck with the assignment. We'll catch you on the flip side.